Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at the this keyword in C++. And this is something that beginners often find very confusing, but as we'll see, it's not that confusing really. Although you won't understand everything about it until you understand pointers, which we'll get onto in a later tutorial. But this tutorial will give us actually our first glimpse of a pointer. So for this tutorial I've created this person class and I've just given it a string name and an int age. We've got a default constructor that I've created here, which doesn't do anything at the moment. And I've also given it a toString method that just outputs, it just returns as a string some information about the class. So let's actually add to this constructor here, the constructor that takes no parameters, which is all we've got here at the moment. Let's add to this some initialization of age, which I'll set to 0, and name, which I'll set to an empty string. Now, in my main function, I've declared an object of this class, and I can use cout by calling toString just to output the information that toString returns. There's nothing standard in C++ about this toString method. It's just what I've chosen to implement. And it says name is, it's blank here, and age is 0 for this object. So let's create a parameterized constructor, a constructor that takes parameters or arguments, you can call them. Let's go to person.h and declare a new constructor, person, and this time I'm going to say string name and let's call it name to start with. Let's say string name and int age. And now I'm going to copy this prototype and save that, and I'll go to person.cpp and we'll implement that constructor. So person : that's the class name, and here's the implementation of the constructor. Now we've got a problem here because I'm passing in arguments as name and age, and in person.h the actual variables that we want to set are already called name and age. So the question is, how can we differentiate these variables, which are in scope here between these brackets, from the instance variables up here, which are also in scope because they exist for any method that belongs to the class? How can we differentiate the two names and the two ages here? Let's first of all write some code that actually uses this before we implement it. So I could say here person 1. Well, actually, let's make this person 1. I'll make this person 2, and we'll supply a name Bob and an age 42, and then we can do a cout on person 2 as well. So that constructor doesn't do anything at the moment, so we won't see anything new here, but the program should run. And again, with a bit of luck, not seeing anything. There we go. We've got age 17. Why is that? That's because if we look at this, I've called this constructor here, but that constructor doesn't set values for age and name, so we've just got garbage in them at the moment. Now, to actually refer to the name that's a part of the class, and so will be part of the individual objects, we can do this. We can type this arrow. So it's a hyphen and a right angle bracket to form an arrow. And autocomplete is helping me here. Let's say name equals name. So here, if I refer to name without any kind of qualification, without anything at the beginning of it, it's going to assume that I mean the local parameter name here. It's going to assume that I mean the name which is most closely defined. That's what we get if we just refer to name without anything before it. If I put this arrow before name, then C++ will know that I mean this name up here. So we can set this name, so this arrow name, equal to name, which is this one here. And that achieves the same as if I'd called this like, new name or something like that, and I'd written name equals new name. So this is the same as that, but let's get rid of that and move this back to name. And we can do the same for age. This arrow age equals age. And this is a very, very common and very useful way to define a constructor. It alleviates the need for you to think up new names for these variables, which after all are exactly the same. They have the same purpose ultimately as these. They're meant to correspond to these. They're just used for setting these values. So normally you get into the habit of creating constructors and also set methods. They're very useful there. You can use this in set methods, and you just say this arrow name equals name, this arrow age equals age, and so on. Let's just see that working. So I'll just run this, and we've got here name Bob, age 42. That's coming from this object here where we're invoking the constructor that we just used. Now what actually is this? Well, what actually is this? Well, as I said earlier, you won't fully understand it until you understand pointers. But let's just investigate it a tiny little bit here. What this is it's a variable that contains the memory location of each individual object that you create. So we call it a pointer. This is a pointer variable. And we can actually output the value of that. Let's try that. Let's do cout this endler. See what we get. And let's run that. So the constructor runs back here when I create the object, and you can see it's outputting this here. It's outputting this stuff. Let's change that a bit so we can say memory location of object. That should do the trick. And if I run this, so it says memory location of object OX and this long string. So what this is 0x is a prefix on a number, means it's going to be specified in hexadecimal. So we know decimal. Decimal is a number system where you have 9 digits from 0 to 9 in each possible position. There are 9. You have one of 9 possible digits that you can use. We've seen binary, where you have one of 2 possible digits in each position, either 0 or 1. This is hexadecimal, where there are 16 digits to choose from that you can use in each position. And because we've only got 0 to 9 in our normal number system, we add the extra digits A, B, C, D, E and F into hexadecimal, and that's why there are F's in here. But you can use like Google or something quite easily to convert this to a decimal number if you want to, but it is just a number, and the X is it's just telling you that this is in hexadecimal, not decimal or something. So it's just a number, and it specifies the actual location in the computer's memory. The whole memory is numbered somehow, and this is specifying where that object, what bit of memory was actually allocated to put this object in, because clearly we need some memory for it to store, for example, the values of variables. So when we create this person object here, at that point memory is allocated in the computer's memory at this particular position, and that's what is stored in this this variable. We could have put this probably in an int, I suppose. Why not? But it is a special variable called this, but at the end of the day it sort of just stores a number, but it also knows that this is a memory address and not simply any number. We can actually see that. So here, when a particular object is created, it's going to output its location. Let's create a new object. Actually, let's create a new one here and say Sue 35 or something, 25, doesn't matter. Let's run this. Of course, we'll get that new object that we've instantiated. Done something wrong there. What did I do? Let's take a look. Redefinition. Oh yeah, I've called it person 2 again. Okay, let's have person 3. Let's run that. So the next object will of course be stored in a different memory location. So they're close to each other, maybe even next to each other, but this ends in 98, this ends in 50 there. So we could find the locations of these objects in memory here in the main program if we wanted to. And to do that, let's say person1.toString, and let's say some punctuation, memory location. And to get the actual memory location of a person or any object in C++, you just preface it with an ampersand like that. So let's say person ampersand person1, and well, I read that often as at person1. Well, it's not actually an at sign, but that's often how I read it. Maybe that's just me. But anyway, yeah, it's probably better to say address person1 because it's the memory address of person1. Let's do that for person2 as well. So let's just copy all this and paste that in person2. Actually, it would be more interesting to do person2 and person3 because there we're running constructors that that actually have this statement in it that are outputting this. So let's do that. So we'll look at person2 and person3, and for those two objects we're running the constructors that actually output the value of this. So let's run this. What we find is that, so we've got memory location of object, that's coming from here, the actual constructor. We've got one that says it ends in 98, and we see here from our main function that the address of, it was actually person2, is 98. So when we created person2, the constructor ran for that object, and at that time when this constructor ran for that particular object, that object resided in this memory location, and that's why this output that particular memory location. When we created person3 here, the constructor ran again, and when it ran again, this had a different value, it had a different memory location, because of course person3 is not in the same location as person2. So then we output this stuff here, and then we output the locations of those two objects, which of course we already know because we output it using this, but we can see the two locations again down here. They're the same two locations as these. Now I wanted to run through this just because it'll kind of sort of soften the blow a bit when you encounter pointers later on. We're going to look at all of this later on. We're going to be looking at this ampersand thing and memory addresses and stuff like that a bit more later on, as well as more stuff besides. But the thing that I'd recommend practicing for this tutorial is very simply create some classes and give them constructors, and also try giving them set methods, and give the constructors and set methods parameters that you've got defined in for your particular object. But then instead of giving them different names in your actual parameters to your set methods or your constructors, give them the same names as the values that they're used to assign to, and then use this to differentiate the two. So just practice doing what I've done here basically in a set method and in a constructor. Try typing stuff like this arrow name equals name, and that will help. Although it's a small thing, it'll help fix it in your memory, and it will also help a lot later on when you encounter pointers, just to already have some familiarity working with this arrow notation. And as for the rest, if the stuff about memory locations went a bit over your head, then don't worry about it, because we're going to revisit this later on, but it's good to already be acquainted with it at this stage. So that's it for this tutorial, and until next time, happy coding.